Alright, let's talk about gravitational force near the surface of the Earth. If we're farther away from the Earth, things start to change. There's different math involved, different formulas, so we're going to stick close to the surface of the Earth. So this young lady has just stepped out of a plane. What forces are acting on her? Gravity is pulling her down, and we can say friction or air resistance is trying to slow her down. When she just steps off the plane, Fg is going to be larger. But as this person starts to fall faster and faster, it's a function of fluids, and air is a fluid. As V gets bigger, the force of friction will get bigger, and therefore over time as she falls, the force from the air will get larger. Yes? Eventually what's going to happen is that Fg will equal this force of friction. And the net force acting on her will become 0. And if there's no net force acting on her, the acceleration will become 0. And V will become constant. If there's no acceleration, V is a constant, and we call this terminal velocity. In English, that's the expression. I gave this formula to you before. The force of gravity is equal to mg, where g is 9.8, and it has two sets of units. We can use meters per second squared, or we could use newtons per kilogram. And if you're not sure about that, I can do that up here. If I rearrange this formula, I get g equals F over m, and F has units of newtons, and mass has units of kilograms, and that's how I got newtons per kilogram. And we call this value the force field or gravitational field strength around the Earth. Is the value of G always going to be the same? Nope. Because as you notice here in this picture, the Earth is not a perfect sphere. Yes. So here we're wider than at the poles. Yes. So here we might get a value of like 9.9, and here we might get a value of something like 9.7, but the average value around the Earth is 9.8, and that's what we're going to be using in this class. Just wanted to point out that it's not always constant because the Earth is not a sphere. And then a couple of terms that we constantly use wrong: mass and weight. Yes? Weight is the force of gravity on an object. It has units of newtons. It also has units of pounds. Mass is the amount of material in an object. It has units of kilograms. Our American friends, the British started this, would use stones. So when you say I weigh 100 kilograms, that's incorrect. You can't use weigh and kilograms at the same time. My weight is 980 newtons. Yes, you can say that. You would have to say my mass is 100 kilograms. That would be correct also. So here's a little intro video is now finished on the force of gravity and how it's measured.